Welcome to a tutorial series where I talk about running NT Helper, the app that I'm currently maintaining and built from scratch over the last 2 years. It's got some depth to it, and I just wanted to show basic operation, how to use it, how to get some interesting things done with it. Okay, I will spend some time getting an oscillator connected, and so let's just pick the VCO wave shaping. So you can go up here and say VCO. We will also need there we go. That's awesome, right? What's going on? The reason is there's default routings. So if we look at the routings here, we can see that it's defaulting. So let's just get rid of that one for now. The other way to do this is to bypass the algorithm. And the reason why it sounded so weird is because we were listening to the clock input through the pitch input. So that's not quite right. So let's, input 3 is the pitch input. So let's set up input 3. And none of the other inputs need to be there at the moment. So let's see what our sequencer is producing right now. Let's just listen to the sine output, and we'll put that into output 1, which will be the left ear. So I've got a delay and a reverb set up in the chain. You may have noticed, but for now, let's just take the volume down on a few of those things, and then I'll spend some time configuring this up. You'll notice that the gate, well, you may not notice that, but this thing has a gate signal coming in, and it's a gate signal that is happening irregularly, but we're not hearing that because all we're hearing is the droning of the oscillator, and we definitely need to tame that down a little bit. So the general way to do that in Eurorack is to use a VCA and an envelope, and disting NT follows a very similar approach. A lot of the algorithms are modular, and they're meant to be used that way. Some algorithms have, extra functionality in them for gating and enveloping the sound and that kind of thing. But some of these sort of low-level algorithms, like the VCO wave shaping, just has one droning output basically. So let's fix that. So we go in here and we say, okay, I want a VCA, and we have this VCA multiplier. I'm just going to use one channel for the VCA. Some algorithms require a specification, and you get prompted for those specifications when you add the algorithm. And we also want an envelope. The NT has two algorithms for envelopes. One is ARAD, which is a simpler version of an envelope, and then there's this envelope DAH, DSR. That one has a few other functions in its envelope shape. One of them is, anyway, I'll just add that, and we'll put those two algorithms in, and we'll wire up our gate signal. Again, we'll just go with one channel, and now we have this kind of haphazard picture. So let's just apply the layout algorithm to this and get it a little bit easier to look at. So we have our VCO on the top. It is currently in slot 1. We have the VCA in slot 2 and the envelope in slot 3. Now if we're going to send signals from one algorithm to another, disting NT has one rule for that, and that is all signals flow downhill, just like a river. Another way to think of it would be each of these algorithms is like an elevator, and if you're on the top floor of a building, you can only send things down the elevator. There's a bunch of ways to look at it. It's kind of like a waterfall model. And so in order for the envelope to affect the VCA, we need the envelope to be above the VCA. So I'm going to move this algorithm up. Okay, and so now the envelope is in slot 2. We can sort of reorganize this if we want. Now, let's set up the inputs and outputs. So the VCA's main input here is, let's just refamiliarize myself with this VCA. So the common input is the input for the main signal, and this input here is the input for the what do you call it? The control voltage signal. And so basically what we want to do is in here we want to have our envelope output go to the control voltage input, and we want the sine output to go to the VCA common input, and we want the VCA output, let's make sure we don't have anything gating right now. So if I connect this output, I am now going to hear absolutely nothing. And that's completely expected because there's nothing happening here. And in fact, I want my trigger input to actually be this gate signal input instead. I don't think we need clock today, but let's also see what the shape is for the envelope. So the envelope shape right now has a very long attack. That's okay, but I'm going to shorten the attack. I'm going to take the decay down as well. Maybe sustain we don't need so high, and the release we'll take down as well. And the attack shape and decay shape are set that way. If you want to see on your disting screen what this envelope looks like, you can double click the envelope up here, and that will show you the actual envelope shape. And so you can, fool around with the attack shape and decay shape. So there's more sort of a linear one. This one's sort of a logarithmic one. And range is how long or short this envelope is. You can go to 1/100th, which is a real snappy envelope, or you can go to 1 multiplied by 100, which would be an extremely slow envelope. Okay. The other thing that we have to make sure is that our channels are enabled. So by default, the envelope channels are not enabled, which I guess makes some sense. So let's enable that. And here we choose the shape we want. We only have one shape, so that's fine. Trigger mode as gate or trigger, depending on what you're looking at. Or you can even loop or trigger by clock, or this trigger no retrigger is kind of interesting too, in that if it's triggering too fast and the envelope hasn't finished yet, it won't re-trigger the envelope. So that's pretty cool, but we want gate. The VCA channel has this input and output. The common is set up here as well. Sometimes if you ask for multiple channels on the specification, the second and third and fourth channel, for example, might be not enabled. So always go in and check to make sure that the channel that you're fiddling with is enabled or not. Otherwise you'll be wondering why sound isn't coming out, or why your modulation isn't working, and it's just because the channel is disabled. All right. The VCO itself is, oh, that's interesting. So there's a gain here. We could have used this as well as the VCA by setting up a routing, but we'll do that sometime later. All right, so I think this should be ready. Let's turn up our gate and see if we start hearing things. So we have sound, but you'll notice that this sequencer that I have is unquantized, which basically means that the voltages don't align to Western scales, or any scale really. They're just all sort of randomly in between the regular notes that we usually hear. And so it sounds odd. I'm not going to say wrong, because there's nothing really wrong in sound generation, electronic music. It's just that you're just not used to hearing it, so it sounds different. So let's add a quantizer. The quantizer is the algorithm that makes the notes. It snaps the notes to regular scales. And even microtonal scales, if you're into that kind of thing, as I know some of you are. So let's have a look. Search for quantizer, and we'll pick the quantizer here. And I'm going to just turn off the clock for a moment, because I know that the default for this is to add the quantizer, and it will actually output directly to the output. So let's add this algorithm. We'll just use one channel, and this quantizer is going to need to be moved up to the top before the VCO, because otherwise we won't have the signal going in the right direction. So I'm just going to slide that up. I use this button up here. You can also use these buttons to do one at a time. And I'm going to look at the routing chart here again. So we have the quantizer going out to output 3. That's not too useful. Let's fix this. So we actually want the CV input of the quantizer to come from the pitch input. We'd like the gate input to be the same, but the gate output will go to our envelope instead. And the CV output will go to the pitch input of the VCO. And that's it, basically. So what did I do there? I basically changed the gate input that I have to go to the gate input on the quantizer, and then it produces a gate output whenever the notes change, because sometimes maybe the pitches will be the same and you don't need to regate. So this will produce the right gates for the right notes and produce envelope outputs for that. And so now in the settings for the quantizer, we can have a look and find that quantizer mode is nearest. That's fine. We're just going to be operating in the key of C. Let's go. I'll just leave it. Chromatic. I like harmonic minor sometimes. And you can hear that it gated because it calculated a new note based on the voltage that's coming in. It's probably receiving a voltage from the sequencer at the moment. And so now we should hear something just a little bit more musical. Well, better for the ears? No. Oh, who cares? I'll just play. Okay, so we're looking at turning on the clock and bringing the gate up. All right. So this sounds all right, but you'll notice that, one thing is off about it. It's only in one ear at the moment. We could change that at the mixer side, but let's introduce a mixer into this flow. Mixers themselves don't really take that much CPU, and so we can have as many of them as we want in the patch, pretty much, or in the preset. So let's pause the gates here and go back and add a mixer. There's mono mixers and stereo mixers, so we're going to look for the stereo mixer. We'll add that algorithm, and we'll say that really we only want one channel, and we'll use one send, and so now what we have in our picture is we have a mixer stereo, and I'm just going to disconnect it. So some connections are required, but that one is the send output. So because we asked for it to have a send, it's sending. It needs a send. So it doesn't have a default of 0, in other words, so that it forces a connection. All right. So we basically want our VCA output to go into the left input of the mixer. And so we'll connect this, and then the left and right outputs are going to go to output 1 and output 2. And the mixer by default, here, let's reorganize this a little bit. By default, the mixer is not doesn't have any gain, and so you really need some gain on that thing. And so you would go to the mixer and go to channel 1, and let's put the gain at 0. Or, yeah, 0 is fine. You can double click this and add your gain directly if you like. Anything that's numeric can just be typed in if you double click them. All right, so I think we should be in the same boat. I'm going to turn on the gate a little bit here. So you can see that that's working just fine. Let's add a stereo send. So in order to do stereo sends, you have to set the width to stereo. And you'll see there now we have send 1L and send 1R, which gives you the left and right sends. And let's add an algorithm like a delay. Or what was that new one that Oz added recently? It had a weird name. It's a bucket brigade. Yeah, adding an effect send. Let's add little spacey. So we'll add that algorithm. Let's just make sure the clock isn't on again, because the defaults often are that the clock signal goes into input 1, and these things will sound pretty nasty. All right, I want little spacey to be stereo, so we'll add that. All right. Little spacey will be getting signal from the mixer. So our algorithm ordering is correct, but I want little spacey to be a send. So I effectively want this send left and send right to go to little spacey. We can set the clock input. I won't do that right now. But you can see that little spacey by default is going to send its audio to the left and right output channels. And you can see that they will be mixed in additive mode. If I click this, then the channels on little spacey will replace the signal that's already going there from the mixer. And you may want that, but in this case I'm just going to add little spacey signal to the output as well. And the last thing that we have to do for a mixer is we have to go back to the channel and set the level that we want to send to the send output. So in this case, I want to increase the send gain for the first send. And so in this case, I'm just going to add maybe -10. And again, I can go here and say -10. And this channel here, we can give a name if we wanted to as well, which is up to you. But here we have little spacey. Let's check its delay parameters. It's got a pretty small bucket brigade delay, and we'll do this. Maybe add a little bit of spread, lots of color, maybe a little feedback. I'm not sure what the feedback path is, but It's fine. Maybe it's feedback on the feedback. So let's hear what that sounds like. So earlier I was saying that if you're in your routing page and you change this, it basically means that Little Spacey's audio will be all that we hear. Right? And then the reason why it's quiet is because in our mixer, in our channel 1, we're actually sending a -10. So let's crank that up a little bit. So now it's +6 dB, probably a little bit of distortion is happening. So I'll leave it maybe at -5. And I'll change it back. So the Little Spacey outputs in the routing page are where you would change the output mode. Right now you can see that it's replace, and that produces a blue line on this chart. If you go to add, then now we're hearing the dry signal as well. In this routing page, we also have the original signal flow diagram style that Oz has in his preset editor, and so you can look at this version of it, and this is more of an elevator diagram style. It shows where the inputs are coming in, and basically the way I understand this works is that the lines above and below each of the algorithms are the inputs and the outputs respectively, and you can see what's immediately connected to things, what lines are replacing other lines, and so on, or signals I should say. I tend to use this one because I'm more familiar with it personally, having written most of it. But it's up to you. Both styles exist, and they're dynamic. So as you're changing things over in the parameters, you can see what they do on the other side. Right. So I hope that gives you a little bit of, I guess, first glance at how to use NT Helper with the disting NT. I'll be making more of these. Please comment if you enjoy this kind of thing and want more, or if you have questions, and maybe I can answer some of those questions in a future video. Thanks very much for watching.